All right, so we're going to continue with flowcharts to organize our reasoning and also talk about maybe some new things that we can use in our flowchart. Flowcharts can also be used to represent everyday situations. For example, yesterday, Joe found out that 3 people in his family, including Joe, wanted to see a movie. So he went to the theater and bought 3 tickets. Unfortunately, while he was gone, 3 more family members decided to go. When everyone arrived at the theater, Joe did not have enough tickets. Joe sat down later that night and tried to create a flowchart to describe what had happened. Apparently, Joe, also a math teacher. Here are the 3 possibilities he came up with. Joe bought 3 tickets for family members. So all 6 members of Joe's family decided to go to see the movie. Now, that doesn't make sense. When we use the arrow, we're saying like this thing caused us to be able to make this conclusion, and they don't work that way. In number 2, Joe bought 3 tickets for his family, so all 6 members of the family decided to go. So Joe did not have enough tickets, so Joe bought 3 tickets for family members, so all 6 members of his family decided to go. This one is cyclical, and it doesn't really describe the situation. And this one says, Joe bought tickets for 3 family members, and all 6 members of his family decided to go to see the movie. So putting those 2 things together, we come to the conclusion that Joe did not have enough tickets. That would be our choice number 3. So there were 2 independent, let's say, scenarios that caused together the third scenario. All right, so the first one did not work, second one did not work. Here we go. For each pair of triangles below, determine if the 2 triangles are congruent. If the triangles are congruent, provide justifications by organizing your work in a flowchart. If the triangles are not congruent, or if there's not enough information to determine congruence, then write cannot be determined. The diagrams are not drawn to scale. So that means we can't pull out a ruler or a protractor and do any sort of measuring. We have to do everything based on the labels provided. So the first one that's there, I might be inclined to start doing a triangle angle sum theorem and say 56 plus 29 plus blank equals 180, 95 plus 56 plus blank equals 180 to try to find those missing angles. However, I don't have any side lengths, not, let alone any corresponding side lengths. So this would be a cannot be determined. And we would say, at best, angle, angle, angle only determines, wow, my handwriting leaves something to be desired today. Angle, angle, angle only determines similarity. So if they happened to both add up to 180 with the 3 matching angles, then you would only be able to say they are similar and not congruent. All right, so B, do not rely on what you see as far as size and shape of the 2 triangles. You have to rely on what you see for symbols, numbers, labels, and such. The first thing I see is that there are 2 right angle symbols. I also see that there are 2 angles that have the single tick mark. So I'm going to start with those. So let's say I want to say angle ABD is congruent to angle CBD. So that's this little angle ABD. That's this one right here. And then CBD is this one here, the ones with the arcs with the single tick mark. So because the arc is there with the single tick mark, that would be a given. The next one would be the ones with the right angles. And those have the right angle symbols. I don't have to tell you that they're congruent. I can see that they're congruent because they have the same symbol. So I could go with angle BDA is congruent to angle BDC. And so that would be the 2 right angles. And that's a given. Notice I'm using 3 letters because I'm describing angles that have more than one possibility at that location. So at vertex B, I could have the one on the top, the one on the bottom, or the whole big angle. At angle D, I could have the one on the top, the one on the bottom, or the straight angle. So I can't just use a single letter. I have to use 3 letters. The last thing is something we haven't talked about before. These 2 triangles both share side BD. So another thing that I can do is say that side BD is congruent to side BD because they share it. So the reasoning for this one is that a segment is congruent to itself. So if two triangles are both using the same segment, we know that that segment is congruent to the segment used by the other triangle because they're the same segment. So using these three pieces of information, we have an angle that's the same. We have another angle that's the same, and then the side that's in between them. So we would say triangle BDA. Remember all kinds of ways to describe these, but if I do BDA, the second one has to be BDC. And we would say that the triangles are congruent by angle, side, angle congruence. And that is purely based on the information provided. I didn't have to add anything up. I didn't have to use the Pythagorean theorem. I didn't have to create anything new. However, because two of them were using the same segment, I did have to use a different reasoning than given. There's no tick mark. There's no symbol for that in your diagram. So you had to say a segment is congruent to itself. In the next picture, again, we don't want to go based on size. We want to go based on symbols and things that we can see. First thing that I can see is they both have an angle with the single arc and that one single tick mark. So I might start with angle GFH is congruent to angle EHF. Notice I did not use FH and HF in the same order. GFH, and then I went EHF. So it does matter that you go around them in the same order, or I should say in consistent order. So this was a given. I can also say, because they're sharing, they're both using this segment, I can say segment FH is congruent to segment FH. And that would be because a segment is congruent to itself. So let me squeak this in here. A segment is congruent to itself. All right. Last but not least, do you notice that two of the sides have this little arrowhead symbol for parallel? So because we know that those two are parallel, we can think of them as sort of like being extended. You know, you can think of like if this were a line and if this were a line and they were extended, we had a lot of properties that had to do with parallel lines being cut by a transversal. So this would be a case where we need to pull things from 8th grade and go, well, you notice this one with the angle and the single arc, this one with the angle and the single arc, they are not using those parallel lines. However, this one and this one are using the parallel line with the transversal. And those were called alternate interior angles. And this one's going to take a bit to recall, to sort of pull back from 8th grade. We would say angle GHF is congruent to angle EFH. And that's by alternate interior angles. All right, so at this point, we can say using one angle, using the segment or the side that is in the middle, and using a second angle. We've got two angles and we've got the segment that's between them. We can say that triangle FHG is congruent to triangle HFE by angle, side, angle congruence. So if I were to draw that picture out here so that it's just a little bit clearer, I've got a pair of parallel lines cut by a transversal. And what we were saying was that this one and this one were opposite interior angles. One is below the transversal, one is above the transversal, but they are both between the parallel lines. So alternate interior angles are congruent. All right, so little refresher from 8th grade. We've got another couple pairs here on the back. D has a pair of triangles, and there are, let's see, one angle that they have in common. Those are your vertical angles. There's no parallel sides. We've got a 6 here and a 6 here. We've got a 4 here. We don't have any other numbers. We don't have any right angles, so we can't use the Pythagorean theorem. This one does not have enough information. So this would be a cannot be determined. We don't have enough information to work with, considering it told us that they were not drawn to scale. All right, last but not least, this one's a little tricky because the triangles are overlapping, and I do encourage people to redraw diagrams that are overlapping in case that is tough. So you have a single arc here in the lower corner, that's A. This is B. Notice angle B is this large obtuse angle. It does not have any symbols. And then C has the 2 tick marks. And then you've got the other one over here that has a 2 tick mark angle at the top. That's D. You've got A. The large angle A does not have any symbols. And then you've got angle B down here, which does have a single tick mark. All right. Do I have any sides in common? I do. They are both using this side AB down here at the bottom. Both triangles use that side. So I want to look at whether or not I can prove congruence. I'm going to say, okay, so this one's got the one with the 2 tick marks, and this one's got the one with the 2 tick marks. This one has a single tick mark and a single tick mark. And then I have a side that they have in common. It wasn't labeled, but because they're both using side AB, we know that it's the same size. All right, so we're going to say, based on the tick marks, angle D is congruent to angle C. That's a given. We can also say that angle, now notice B could be this small angle, or a big angle. A could be this small angle, or the big angle. So we have to be really careful that we can't say angle B and angle A. We have to use the 3 letters. So angle CAB, which is describing this angle A that has the single tick mark, is congruent to angle DBA, which is describing this small angle with the single tick mark. That is a given because it was provided the arc with the single tick. And then the side that they share, side AB, is congruent to side AB. And we know that because a segment is congruent to itself. And based on those 3, we've got an angle, and then the side that is not included between them, an angle, and a side that's not included. Notice the side that's not included has it's adjacent to the arc with the single tick mark. And over here, the side that's not included is adjacent to the one with the single tick mark. So we are good. That is a corresponding side. Triangle CAB is congruent to triangle DBA. And we would say angle, side congruence. All right, so the last question that's on here, 744, is looking at that square. What single rigid, oh, I'm sorry, that's not the square one. Which single rigid transformation would show congruence of triangle CAB and DBA in part E of the last problem? What could we use? I would do a reflection. I would reflect over AB, the side that's here at the bottom, at the, let's see, reflect across the line. No, I wouldn't want to reflect over AB. I'd want to reflect over the line perpendicular to segment AB. So if I drew a line like right here down the middle, and I reflected from the left side to the right side, that should do it. I know they don't look like they are congruent. We already discussed that. But if I reflected across this midpoint of AB, that should work. It should flip it over that line, and it should be one right on top of the other. If not, I might have to translate just a bit. So possibly need to translate. All right, 745. Consider the square MNPQ with diagonals intersecting at point R as shown at the right. So we've got a square. They connected M to P, N to Q, and they intersect right at the center at point R. How many triangles are in this diagram? So we've got sort of an upper half and a lower half. using NQ. We've got an upper half and a lower half using MP. And then we've also got the 4 smaller triangles. So there's actually a total of 8 triangles. How many lines of symmetry does the square have? Well, the 2 that are already here, NQ is a line of symmetry, MP is a line of symmetry, but you could also do one that is vertical and you could do one that's horizontal. So it has 4 lines of symmetry. So if I went, I could do a dashed line for the horizontal, a dashed line for the vertical. I read what I wrote, dashed line through NQ and a dashed line through MP. So there's your 4 lines of symmetry. Write as many triangle congruent statements as you can that involve the triangles in this diagram. Justify each congruence statement that you write. So there's actually, and there's a lot of statements that you could make here. We could start with the 4 small ones. So we could say triangle MRN is congruent to triangle NRP is congruent to triangle PRQ is congruent to triangle QRM. Those are the 4 small ones. Those are all using the fact that they are sharing sides, that you are bisecting angles, things like that. And we could also go with the larger ones. So triangle QMN is congruent to triangle NPQ is congruent to triangle. Now that one used, let's see, QMN, NPQ. So now I've got to use the other side, MNP, congruent to triangle PQM. Those are the 4 large ones. So the 4 small ones are congruent. The 4 large ones are congruent. Lots of different ways you could write that based on what order you decided to go around each one of the triangles. But that's probably the most concise. So using congruent corresponding parts, the fact that you're bisecting right angles, so you've got 45-degree angles, lots of different things you could use to justify this. And there's a great sort of more concise answer as well on the provided filled in notes. All right, can't wait to see you guys.